Three. Hi guys, I'm Carl.
I'm Mila. And I'm Malia.
And we're going to be talking about the car quest, and specifically three concepts, which is momentum, gravity, and thrust. So Malia's going to do a quick demonstration of momentum.
Okay, so you can try this at home if you would like. It's really cool. All you need is a ruler, a quarter, and a penny. Okay. Now you can put them at the very tips. Let's see what happens when you do this. So the quarter just translated its momentum through the ruler to the penny, and that's how the penny moved. Now let's try it the other way. The quarter only moved a little bit because the quarter weighs,
More.
It weighs more mass.
It weighs more.
Yeah. And then without momentum, this car, as soon as you let go of it, it won't move. But with momentum,
It carries on going.
and that is momentum. Now, Mila. Gravity. Gravity is the force that pulls things to Earth.
Such as that lump of Play-Doh.
So whenever we throw something up, it must come down. So,
Yes.
the Earth has gravity around it, and whenever someone on the Earth throws something up, it comes down. And the bigger the planet is, the more gravity it has, and the faster the things come down.
Yeah, and also,
Thrust.
so gravity is very important in life because without it, we would just be floating around. And imagine shells without gravity. Everything would just fly out and float around in there. So there would be zero organization in our daily life without gravity.
And now we will do thrust. Thrust is the force that pulls things, pushes things,
Forward.
Forward, okay. I cannot read that. Sorry, Carl.
Here's a demonstration from Mila.
Carl, can you just
So the thrust is what comes out of the straw, and this demonstrates Newton's third law. Every action has an equal and opposite reaction. You see, the air comes out this way, which is the action,
And the
then
car
the
goes the
opposite,
opposite.
and then the opposite reaction is it goes
forward? And that's all we have. Do you have any questions?
Thank you.
Welcome to the wonderful world of civil machines. First of all, what are civil machines? Civil machines are tools such as pulleys, levers, wheels, axles, and more, which can accomplish simple tasks, which can help us in our everyday lives. Civil machines usually have a load, force, fulcrum, and wheels. They use forces such as pulling, pushing, or lifting to accomplish tasks. Next, we have Sophia demonstrating how levers work.
How levers work? It's like a seesaw. So basically, you put a load, like a child, and that child will go down. The seesaw will go up. But if you put a force, like a parent, the child will go up. The parent will go down. All these objects have lives.
We can describe that using pennies as our load. Let's say we put 3 pennies onto this side to the store. We put 3 pennies onto the side. Now we can see, as in this picture, the load has a force that's going to go down. But if we were to put twice the amount of pennies on the other side, it would now go down on the other side, as in this demonstration. Next, we have Charlie presenting how pulleys work. So this is how pulleys work. So basically, first there's the wheel and the rope, the 2 magnets, and the rope that goes around the wheel. And then we have the load, which in this case is a bucket. It can be anything attached to this side of the rope, or on the to this left side of the rope. And on the opposite side of the rope is the force, which in this case is a person pulling the rope down. As we can see in this demonstration, when I pull this rope down, the load, which is a penny wall will go up. And when it forces no longer going right to it, the load will go out. And the reason why pulley is more efficient than just carrying something up is that when the wheel is when the rope goes around the wheel, the pulling something down is pretty much easier than pulling something up. And when the load when you pull it down, the wheel does the work of bringing the load down for you, so that the load can go up. Now, next, I will explain. Simple machines are everywhere. Like in a car, you can find a wheel and axle on the wheels. In all, you can actually be selected with the load, the force, and the front. A nutcracker can also be the same. In an elevator, you can work as a pulley with its wheel, ropes, and load. Now we have Sophia demonstrating our other simple machines.
Other simple machines. A wheel axle, a wedge, a screw, an inclined plane, a slingshot. Here are some examples. So like, I would do that.
So it's a pulley and attached to a lever to make a kind of pulley. Please.
Pull it back up. 2, 1, go. Okay. Next, we have an inclined plane. An inclined plane is used for planes to take off. Also a ramp. Look, 3, 2, 1, go. It goes pretty far.
Yeah, it uses the force of gravity. Since you know the force of gravity, it can't. Since it's on the top of the plane, the gravity isn't strong enough to pull it down through the top and make it break through everything. So instead, it just pulls it down to the bottom so it can go closer to the ground. And next, we have a Play-Doh bottle of a wedge.
Yes. It's used like for an axe or stuff like that. It's like 2 pieces. Like sometimes when you have a cavity, they fill it up with a wedge. Yeah. And here we have a wheel axle. Like if you know those things in the airport that when you push on the handle they roll, but if you don't push on the handle they cannot roll? That's what it would be like if cars didn't have a wheel axle. It will go beep, beep. You guys want to turn to do it? Like roll it?
And now let's present this one.
Okay, now give it back. And now for you, Will.
Okay, now we can present the slingshot.
Going one. 2, 1, go.
Wow! Now can you explain it, Sophia?
And a slingshot was used for many things in the old time. It also was used for like a weapon or something.
This is a model of a slingshot that I made a few weeks ago. It doesn't really work that well, but it still works as a slingshot.
Wow. My name is Alana. My name is Jordan. And my name is Josie. And we'll be teaching you what a Da Vinci Bridge is and who Leonardo da Vinci is. So, who was Leonardo da Vinci? He was a brilliant artist, sculptor, and also he was a scientist. When did Da Vinci build his first bridge? He built it in 1502. What was Da Vinci's longest bridge? 280 meters. Although the bridge was never built, engineers in Massachusetts used technology to test the bridge. Why did Da Vinci build his bridges? The National River estuary separated the cities of Gagaland. I don't know what that says. Da Vinci's bridge is so famous because he had nothing to hold it underneath. Together. And these are some of his prototypes, like this. And then this was inspired by Leonardo da Vinci. And then this is how to make how to make Leonardo's bridge. And that's Leonardo da Vinci. Looks more like a portrait of him. That's it. Thank you. Bye. Hi, I'm Scarlett and I'm 12.
Hi, I'm Natalia and I'm 11.
And we're the toy physics team.
So we're going to be showing you what toys we make.
what toys we made and what electricity, momentum, buoyancy, and gravity and friction all means.
So I made a bouncy ball and I put putty in it and I put a balloon on the outside and it bounces pretty high. And I also made one with like a squishy slime in it and that one doesn't bounce as high. This one's more bouncy because it uses elasticity and momentum to bounce back up, and it also follows the law. Every action has an equal and opposite reaction when it bounces right back up.
And I made a catapult, so I'm gonna try it with the squishies. And first, we're gonna try it with the slime one, and then we'll try it with the harder one to see which one goes further. So with this thingy, it goes not that far, but then with this one, it goes way further. Goes all the way over there, and mine uses gravity and momentum. It uses gravity because when we use the ball, without gravity it just probably float away once it goes in the air, but gravity makes it come back to the ground, and then with it uses momentum because this goes like that, and then this hits the wood back here. You guys probably can't see it, but
And
this
this
is
is a
wood.
weight.
And this is a weight, it's metal, it hits it, and then once that hits it, this shoots it. And then momentum is basically something that, it's a force that keeps things, it basically makes things go faster and further. For example, when you're going down a hill with your bike, you gather up momentum to go up a hill, so it's easier to go up. It makes it easier because it's a force. And then, but if you wouldn't get momentum when you go down the hill, you'd probably get stuck in the middle of the hill. So,
Yeah.
So we have a game for you guys.
it's called the Big Physics Minute.
The Big Physics 20 seconds.
And we have probably explained with our toys and with other stations what elasticity, momentum, buoyancy, gravity, and friction is. And we're going to point to each drawing, and you're going to say what of these four it uses.
Or do you want us to just say what they are?
Same.
So this uses elasticity because it can stretch and it can return to its original
It
shape.
comes back to the front.
Similar to the squishy because it can stretch since it has stretchy putty, then it easily goes back to its shape.
And then this uses, this one uses also gravity because a slide stays on the floor. And
It also uses friction
and it also uses
because it helps you go down the slide.
because it gives you. This one uses elasticity because once you shoot the bow and arrow, the rubber band goes back to the original spot. And this fidget spinner uses
Friction and momentum because you don't have to keep spinning it for it to move.
gathers up momentum to keep on spinning.
This swing uses momentum, friction. This swing uses lots of these. And it also uses for every action as an opposite and equal reaction. Because when you push forward, you need to go backwards. Without that, you just go forward and stay there.
And this one uses momentum because once you start pedaling on a swing, you pedal and pedal. So after a little bit, you don't have to pedal anymore, but you're still moving.
And these Newton's cars with the balloon-powered cars where you blow it, then you let it go and it shoots the air out.
And yeah, that's our station. So thank you for stopping by and hearing our presentation.
And we're in the Discovery 2 studio.
Bye.
Hi, we're here to teach you about buoyancy. Buoyancy is something that makes a boat float. Without, it's kind of like tug of war. The gravity pulls it down and buoyancy pushes it up. But you would wonder, cargo ships and big cruises have a lot of weight. Why do they float?
Cargo ships and cruises float because it has a part at the bottom of the boat that is just filled with air. The styrofoam is filled with air out of these little bubbles in it. So it makes it float. And it can hold weight because of its buoyancy.
And if we didn't have airplanes and we just had boats, we needed the buoyancy to help the boat float. without the buoyancy, the boat would just sink like that. That boat sinks because it doesn't have any air in it.
And the popsicle sticks are absorbing the water.
Any questions? So, we're doing Rube Goldberg machine station, and a Rube Goldberg machine is basically a machine that can do a very simple task, ring bells, like here we have the start domino train, but in a very complicated way. They often use marble runs. Here we have a graph, just like a really complicated run. They often use pulleys, levers, gravity, and momentum.
Sure. So this is an example of ring the bells. It will start over here. The track will go around into this track, into the spiral. There's another track that pulls down the pony with weight and momentum. I mean, just weight. Then it goes down here, hits the lever, and then it makes it go down in here. And then hits the bell. That's the simple task that we do out.
This is our one. Please don't touch it because it's very delicate.
Sometimes it works, sometimes it doesn't.
We have to get it in the right place though. Every single time. It goes out, it does literally
What just happened?
You can definitely tip one domino. We can tip one. Trying two. We're trying three. Ah, come on.
Hi, my name is Serena, and today I'm going to teach you about elasticity. Elasticity is when you stretch something, and then when you let go, it comes back to its original shape. All of these things below here, all of these things are all have elasticity. Elasticity is very important because back in time before people had guns and swords and stuff like that to shoot people, they had bow and arrows and they had slingshots. Slingshots they both have elasticity because without elasticity, first you have to shoot it through, right? The second time you shoot it, if it doesn't have elasticity, it might not be in the same shape, and then it might go boing, 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 boing. And then if it just goes everywhere, it won't even be a slingshot. It'll just be a thing that you're just shooting everywhere, boom, 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 and it's not going to be how you want it. Now, we have a quick challenge, if you'd like to accept it, where you have these three things, and you have to choose which one of these three things has elasticity. Okay, and now you have to just explain what elasticity means.
Elasticity is when a shape can be stretched and returns to its original size.
Yes, that's precisely. That's what elasticity is. Now, elasticity is exactly like that, and you win a prize of getting to touch one of these things. One of these two things. I said these two. For example, this thing is bouncy. This one is a net, or it can play music. This one is stretchy. And then Kayla. This one is like a ring and it's also stretchy. And then this one is kind of like yo-yo. Ouch. And then, yeah, thanks for coming. Thanks for having my conversation. Bye.